Hello and welcome to the advanced topics in Python. Today is the fourth session. This series is important for people who already have an intermediate level of understanding in Python and want to understand the advanced topics to become expert. A little bit of myself. I am Anant Tirmanor. I have been working in data analytics, data visualization for over 16 years. I previously covered the comprehension, map, filter, reduce functions, zip functions. We covered Lambda functions in the second session. We covered the magic functions and dunder functions the second session. The third session we covered generators, and we did a little bit of introduction to the decorators. Today's session we'll go back and revisit what we did for decorators. We'll go a little bit more in depth, and then we'll cover the next topic of hashability. Today is the final session. If you have any questions or comments, please don't hesitate to ask. Thank you so much. As always, if you like this content, hit the like button, subscribe to our channel. A lot more content is coming up. Let's go back into decorators. So we did touch about decorators a little bit in the last session, but I'll go back into what it is and why we need it and how we use it. Decorator is a design pattern. Say there is a function, you want to add some function or wrap that function around and do certain things, then that's where you use decorators. How I use it in my work is typically when I have a function and I want to log it, I want to create a logger for each function. So whenever some of the functions like do something with the data, I want to log whatever happened before that, not only for a timing perspective, also for sometimes to trace it. I would log those things. So for the logging functions, I put them in a wrapper function, and I use this at condition and I put it above whatever function I have. And that way, whatever function I have gets wrapped by the logging function. So whenever the function I call happens, it gets wrapped by the wrapping function. The wrapping function is where the logging happens. And I can use that wrapped function across multiple functions that I write. And all those functions can get wrapped, and all the data that we need will get logged up. Apart from that, let's try running this. So what, before I run it, we did see it last week. Let me quickly explain it for people who are looking at it the first time or still have a tougher time understanding. So here we are defining the decorator function, and each decorator function needs to have a wrapper. It needs to have the name wrapper in it, but essentially it needs to have a function called wrapper defined, and that wrapper is what is returned back. And inside this wrapper function, we pass the function in the original function. That, like, whenever somebody calls this, it looks up and it sees that there is a decorator function. So it goes in and calls the decorator function, and this function becomes an input for the decorator function. So say hi is the input into uppercase decorator, and then it would go in here. It sees a method definition, so it passes through that, and then it looks for any other execution statements. The first one is a return statement, so it tries to return it, but the return, whatever is getting returned, is actually the wrapper function. So the wrapper function gets executed. So in the wrapper function, the first thing we do is we call the function that was passed. That is it. In this case, we call say hi, and the say hi gets called here, and then these are just principles that we're trying to debug or understand how it works. But the next actual statement that happens is we call the we into the make uppercase variable, um, we pass on the value that came out from the function. So this value returned from this function, so it has to be hello there. So that gets turned into uppercase, and then we return this variable. So this variable gets returned here to func, and func.upper makes it uppercase hello there, and then that gets returned by this function. So whenever somebody calls this function, because there's a decorator, we would actually get this value uppercase hello there instead of this value, which is hello there in lowercase. So let's try executing that out. So here, and then let's execute this. So if you see, we called the function say hi. It did not directly go in there and print 1.2. It did not execute the first statement here. As soon as it calls this function, it looks at the decorator and it goes up to the decorator function and it starts looking for return wrapper. So it prints this, then it goes to return wrapper, and because the wrapper is here, it prints 1.1, and then it makes the function call. So it calls the function say hi now. So even though we actually wanted say hi to be executed, this is when say hi gets executed. And when say hi gets executed, it returns lowercase hello there to func. So if you see that, it's got printed out here. This print function prints out hello there. And this 1.3 gets printed out here. And then here we make it uppercase and it's turned into uppercase hello there. Now we print make uppercase and then we go on to return this value. So when we get this, we actually get the value uppercase hello there. So this return value becomes hello upper there. So say we want to write another function, and we want to execute that. So let's try that. And if you want to use the same decorator, say we use the uppercase decorator, and we define another function. This is great. Say we want to return this is great. And if I execute this is great function, so again what is going to happen is, because we have a decorator here, it's going to go in here and execute all this and then get this in uppercase. So let's try that. So if you see what got returned here, it is this is great. Say I want to like not use the decorator. All I do is take it off, comment it out, and then I get back just this statement and we return back this. So that's how decorators are used and decorators are executed in the real world. Let's go into a little bit of a slightly different example. Say what if we have two decorators? I want to do two things. I want to do an uppercase decorator and I want to do a split string, and both these refer to this function. So when we want to do both, how does Python execute it? So if you look at this, I'm going to define another decorator function. So each decorator function needs a wrapper. So I'm going to define a wrapper, and then I'm going to return the wrapper as the output. So that's how the decorator functions are typically defined. Um, and within the wrapper function, I call our function. So the function that gets passed is executed here. You could execute it like 10 lines down after you do a bunch of other things, but within the wrapper is where we execute the function. And in this example, we get the returned value here, and then we split that into a splitted string. So here, based on spaces, it gets split. So I'm going to say the say hi function is going to return, hello there, this is a Python advanced class. And what would happen is that gets returned into the function dot split. So that would split it into like 1, 2, 3, 4, 5, 6, 7, 8 different strings, and those would be in a list, and that gets returned out. So here, if you our original function returns a string which is a long one, but our decorated one returns a splitted string which is actually a list. So let's try this out. Let's first execute this. So one important note when you use multiple decorators is that please notice that the decorators are executed from the bottom up. So the first thing that gets executed is the uppercase decorator. So this function gets passed to the uppercase decorator, and then that function in turn gets passed to the split string. So let's do this without the uppercase decorator. So in this case, what should happen is we pass on this long string. Inside the wrapper, this function gets called. So it gets called. That is then split, and then the return is the split of this. So if we just do just the split string decorator, and then we call say hi, we get this string split into different strings based on the space, and then put it to a list. If I also use the uppercase decorator, you must remember that in the uppercase decorator, what happens is this whole string, one string, gets converted into a uppercase string, and then it gets returned. So that's what this does. And the split string just splits the string out and sends out. So we should have both these operations done, and we'll have a uppercase hello there is a Python advanced class list printed out. So if you see the output, we actually see what we expect. So we see a list which says hello there is a Python advanced class, but the uppercase decorator actually converted the lowercase into uppercase, and the split string decorator split the string into a list. So these two things happen. The order is important here. So the bottom one is the first one that gets executed. This one is the second one that gets executed. Say if I want to change the order of this, in this scenario it won't work because what happens is the split string returns a list, and the uppercase decorator does not have any condition for list. So if you look at this, the uppercase decorator, it calls the function. So in this case, it will call the uppercase decorator would have input as a split string, and then when we call the split string dot upper, so list dot upper, so list this would actually be a list, because we already do a split string, list.upper is not a valid case. So in that case, this would not even execute. So let's go back here. So now that I change the order of this, I believe that this split string would return a list, and the uppercase decorator would convert string to a uppercase. And in this scenario, because we're first doing a list and then the list gets sent out to uppercase decorator, this would not work, and we would get an attribute error because it says list object has if you see the error here, it says list object has no attribute upper. And as you saw earlier, if we just replace the order here, that should work, and we should get back the uppercase. In this case, what happened is the uppercase decorator got called first, and then the split string got called. So here, if you see, this is one easy statement we're doing, and we're calling say hi. Just because it has two decorators, the way this get executed, the order of operation of this would be at first the uppercase decorator would get called, and then in turn that would call the split string, and in turn that would call our function say hi. So even though, like any place in the program, we're calling our method that we wrote, because it has decorators, it actually calls the lowermost decorator first. So it calls this, and this has a function call, which the uppercase decorator has a function call. It has it passes the function. So for example, let me go back here. So the uppercase function has a parameter function. This function actually would be the topmost decorator, so it would be split string. So the split string function gets called here, and then within the split string function, another function gets called. This is where the say hi function gets called. So the say hi function gets called here. So that's how it works. So this is the order of execution. The uppercase calls split string, then it's called say hi. Okay, let's move on to the next one. We saw easy decorator functions where we had no arguments in the inputs. Typically, when we use decorators, we have multiple arguments, and in the example I said earlier, there could be multiple methods, some of them with one argument, some of them with 5 arguments, some of them with 10 arguments, some of them with no arguments. If you want to build a decorator that takes care of all those cases, and it needs to work for all those cases, we need to have decorator with arguments. But as a first step, let's look at a decorator with arguments, which is going to explain how it works in the world where the decorator has arguments. In the next step, we look at general purpose decorators, where we define the functions with multiple arguments, and these decorators would work with for everything from with 1 argument to 0 arguments to 10 arguments to any kind of ranges. If you want that to work, then we use this kind of general purpose decorators. So but let's look at a simpler case now. We want to accept arguments in a decorator function. How do we do that? So if you look at this is a decorator we are defining. It does have a wrapper function, and we are returning the wrapper. So this definitely is a decorator. So we decorate the cities function with this decorator. So what is the decorator doing? It does nothing. It prints out my arguments and then it makes a function call. It does not like store the value from the function. It does not modify. In the earlier case, what we saw was we made a function call, we stored that in a variable, and then we either split the string or made it in uppercase and then returned that variable. But we're not doing anything like that here. All we're doing is no return statements. I'm just doing a print statement. This is just to understand how wrapper with arguments work. So all we're doing is the arguments that get passed are passed in this. So this is our original method that gets passed. In the method, we're calling these two parameters. So when we call cities with London and Melbourne, we would love to live. We want to print. We would love to live in London and Melbourne. But if you want to decorate this function with arguments and say that I want to do something before I do this, before I actually print this, I want to do something else. So if you want to modify this without modifying this function itself, then you add a decorator, and in the decorator, you say print my arguments are London and Melbourne, and then it would actually call our function with the same two arguments. So it will call it with London and Melbourne, and then it will go here. So let's look at it again. So when we call this cities, it first executes the decorator, and in the decorator it has a print statement, and these two arguments args are from cities call. And then it does a print statement. So this is what it would do next, and then it would call the function. Here it would call cities function with inputs London and Melbourne. So the original inputs that came here don't directly go into this. They go into this, and this gets called onto this. For instance, if you want to do this, so if you want to call our cities function with the London in uppercase, we could do it this way. And say I want to like just have 0 to 3. So I don't want the full string, I would just want a part of the string to be passed. So in this case, it would call the function with the uppercase London, and I believe MEL or a part of it, either MEL or MELB or something like that. So that's what would call here. So when we print this, we would only pass these variables, not these variables. So that way we'll have a different output. So let's try that out. So if you look at this, the first print statement, it printed my arguments are London and Melbourne. But when we call the second function call, so this is actually calls our cities function. So here we are passing the uppercase London, so it prints out uppercase London and the first 3 characters of Melbourne, which is this. So in this case, we have arguments here, and we are able to execute the decorator functions. So one thing we notice is if I don't have the arguments here and say I'm calling it without arguments, it wouldn't work. Say if I have the arguments here, then the first part, so it errors out at the initial call level when the city executes. Now if I have the arguments here, let's try this, and I actually call the function without arguments. That means it calls this without arguments. Let's see how that works. So if you see, the first call goes through and goes into the decorator. It returns the wrapper function, so it goes in here. It runs the print statement, but when it runs the function, we don't have those arguments, so it doesn't work. But if you have the arguments or the same number of arguments which are strings in this, then they would work fine. So it's very important to note that the number of arguments here, the type of arguments, if this is a string and this is a string, we need to pass strings here so that it works efficiently within the method. So we need to make sure that the number of arguments and the type of arguments are always correct. But with decorator functions, we want to be able to use it in multiple methods. How do you know like which method has how many arguments? How do we like adjust it according to what we need? So that's where we get into the next topic of defining general purpose decorators. So general purpose decorators can be applied to any function. We use the star args and the star star quags. These are like args collect all the positional arguments and quags collects all the keyword arguments. So whenever you want to have like I think you with intermediate knowledge of Python, you guys already know what positional arguments are. That is based on position 1, 2, 3, 4, or based on keywords. So if you have city1 equal to, and then you have a string, then those are keyword arguments. So we could have either of them here, and whatever they are, if somebody passes it with position arguments and keyword arguments, are just position arguments, are just keyword arguments, or a combination of both, in any way they pass it, we have this defined so that it can take care of it. So if you have not done much with args quags, I think this is a good start. But if you've done a lot of functions with args quags, this should be pretty easy for you. With respect to the decorators, so let's look at this. We again have two decorators here. What we want to do is we just want to make sure our decorator function works. I'm going to keep it really simple. As far as you understand the concept, you'll always be able to implement it in your work. So I'm just having a function that just prints whatever is passed here. So if I pass here who are you, it prints it out. So it all the message, all the function that I wanted to do is to just print it out. But the person who's looking at the reports, who looks at this, says, oh no, I want that to be specially highlighted. So can I have it like around percentage printed out like this? So I say, okay, let's print about 25 percentages numbers there, and then that should cover it. So what we do is we wrap it around a 25 percentage, and then we also get another comment saying let's also wrap that around these stars, so that when they look at the report, it's easy for them to identify. So this is what we want to do. So what we do is we call a function called percent as the first wrapper function, and that what it does is, as usual, this is the wrapper function. because we're returning the wrapper function here. And the wrapper function takes the argument args quargs. So it takes multiple arguments. How many ever arguments there are, it will work. And then it just does a print percentage 25 percentage times 25. So 25 times it prints the percentage before, then it calls the function, and then it prints percentage again. So it before it calls the function, it prints out the percentage, it calls the function, and then it prints percentage again. But that again is wrapped in star. So what happens is this wouldn't end necessarily here. That would get called by this function, and when this function is called by this function, so we then wrap this function inside here, and that function has print 30 times of star and print 30 times of star before and after this function call. So the first function call that happens would be the percent, but that gets wrapped around by star. So the star is what is the outermost function. So this gets printed out first, then this gets called percent, and when percent gets called, this prints this percentage, and then it calls the printer, and then it executes this, goes back to star, it executes this, then goes back, and we're all done. So that's how the processing of this works. So let's try that out. So if we print this, it says the first line is as we expected this, and then this function call goes on to call the inner functions, and then this, and after that this calls the actual printer function. So it goes and prints message. So if you look at this, this is number 1, and then it calls this number 2, it goes here number 3, and then it goes here for number 4. This is a call to percent, so it goes number 5, and then it goes back here number 6, and because this gets returned back here, it calls here number 7, and after that it returns. After that we're done. So that is how this gets executed in that order. Obviously, if we take off the percentage, we're just going to have one wrapper function. We're just going to have the stars print around who are you, and if we have it in the other order, percentage then star, we'll have the percentages first, then the star, then who are you. So the number is these numbers of execution are different. It's no longer number 1 here and number 2 here. So that's how it gets executed. So that should give you a good idea on how general purpose decorators are used. Before we get out of decorators and go into our next topic of hashability for the next 30 minutes, let's talk about how decorators are useful. I don't use the first case, but the other 3 cases I've been using in my work all the time. The first use case here is authorization in Python frameworks such as Flask and Django. The next one is logging. This I use all the time. So whenever we have logging, we do it on AWS these days. AWS X-ray trace functions. We call those decorators, and those X-ray traces are very essential for like understanding any errors or logging for time, elapsed times, and all those things. It also helps measure execution time. So when we have a decoration function where we can log the time somewhere, or like go in and update times in a database, so we can measure the execution time of each function before and after. And when the function gets wrapped around, so you can measure the time before and measure the time after that function gets executed. So that is very useful use case for decorators. You can also use it for synchronization. So whenever we want to synchronize like multiple operations, then that decorators are a huge advantage. Okay, the next topic we're going to cover today is hashability. This is a very tough topic for me, and I've taken a lot of time to understand hashability. It was Python makes hashability very easy, but for people from other like programming backgrounds would probably have to have understood hashability much more, because there's you'll have to implement it in a slightly more difficult fashion. In Python, dictionaries are something you've worked with. You definitely would have already done a part of hashability, so you would have already understood how dictionaries are implemented. Even though we implement dictionaries, we may not understand all the aspects of hashability, so I'm trying to cover a piece of it here. And hashability is a huge topic. I don't understand all of it, like with starting with hash maps to how the servers that we use are hashed so that they don't get reused. Uh, so those are a lot of places where hashability gets used. Hashability is also used when you actually index your data, large amounts of data. Um, that's another place where hashability gets used. When we use databases and packages that already are provided, it's most of it is internally taken care. Most of the hashability is internally taken care by the packages that you use or the programming languages that you use. But it's a very important topic to understand whenever you want to go into advanced programming. So let's dig into it. Um, when we build a hash like dictionary in Python, um, we we just define it like open a curly braces, put in all the name value pairs. So all these get into the dictionary with this as the reference and this being the value. So when you want to store say phone numbers, we put in the person numbers or person IDs, and then we put in um, their phone numbers here. So whenever somebody wants to reference like person six's phone number, Python does not have to go ahead and like go through a list and like go through that one by one. Say if there are a million elements and you want to go through the 500,000th element, you don't have to go through half the list to get the phone number. You don't have to work through that. The dictionary helps in indexing these. So what happens is within that, if we have to quickly get to person six, like the dictionary has a hash map. When we do a get, we are quickly able to get um, say let's say I want to get the person six's phone number. That was Python does not have to go through each of these and do it. This get function, what it does is it has these indexes for these hashed values of these stored in a location, and it has the address of this value. So whenever you go to person 6, the hash value for that would show where the value of this is. So it will hash person 6, go to that location, find the value, find the address of the where the value is, the memory address, and in that memory address it will find this value and then it will spit it out. Not only can we do a get, we can also do a pop. say if you want to pop the person 6 that we just looked up, I can go ahead and pop that, and then what will happen is I get a dictionary where person 6 is missing. I can also add it back. So if I want to add back the person 6's phone number, or if you want to update it, let's do this. So two things we can see here. One is we are adding a number that we deleted. So we deleted person 6. I'm going to add it back. And I'm also going to update the person 3's number from 7070707007 to 333333. And I want to update the person 4 to be ones, all ones, from what it is earlier. So all these things can be done using these two types of statements. One is the update method. So if you use the update method and you provide the name and the value, it gets updated. Or if you use the like the equal to updater with the ID, the key value here, that gets updated or added. So let's try that. So in this case, we added person 6 back. So if you look at that person 6, it got added back. And then we replace the person 3 with a new value. So person 3 was 70707. Now it's now 33333. We also updated person 4. So if you look at person 4 earlier, now we updated it the new value. So we can use both the update and this particular logic to update the data in place. And we can also I think we're just printing it out here. We're updating person 1, person 11. So we're adding one more to have this number. So that kind of covers how we use dictionary and how Python somewhat internally does all this logic. Okay, so let's go on to the next one. Hash table is a type of data structure that maps keys to its values. So it's called a key value pair, and it basically uses a function that computes an index value and in turn holds the elements to be searched, inserted, removed, etc. This way, Python makes it much faster and easier to access the data. In general, the hash tables store key value pairs, and the key is generated using a hash function. So the hash function is what like we get the key from. So internally, when we store a dictionary like this, what we would want to do is we want to use a hash function that computes an index value. So whenever you put in person 1 or a person 10, it internally computes an index value for that, and that is how the key is like stored. There is some difference between hash tables and hash maps. The major difference between those two are that hash tables are synchronized and hash maps are not. Whatever we're doing in Python is actually the hash table. Hash maps are not something we're going to cover today, but if you want to understand a little bit more, you can look it up. And the main thing you need to understand is that hash tables are synchronized, but hash maps are not. I can also cover it in the next future video, and I'll put a link to it in the bottom description. Let's look at how Python does this as well. It's not only just pop update. You can also find the length of it in a quick fashion using Python. And there are many other methods as well that Python allows us to do. So if you look at this, there's a class A and I have 3 names value pairs. And when you want to count the number of elements, Python has a way to quickly count them and then provide the length. Dictionaries not only have the length, the pop, the update, there are many other important functions that dictionaries implement. One is copy keys, and it returns a list of all the keys. Values, items, and you can compare two dictionaries using this. So let's try that. So we have a class A, and let's say there's a class B, which is equal to class A dot copy. Class B dot items would return all the items in class A. Let's try class B because we copied it. We want to see what happened with class B. And class B dot items prints out the same list. If we wanted to do class A or class B, class A dot keys, and you want to print those, it should give you just the keys. And if you want to do the values, use the values button, values method, and that would print just the values. And we did the keys, we did the values, we did the items. Now if you want to compare dictionary 1 and dictionary 2, then we can compare them using class A comma class B, and this just returns true or false. I'm sorry, I'm all I want to do is I want to compare class A with class B. I don't know what I was doing. So if I want to do this, so let me try that. Okay, sorry, the compare function can only be used in Python 2. I'm on Python 3.8, so that's the reason it's not working. But if you want to check if dictionary 1 and dictionary 2 are equal, then I believe, let's look at what are the methods there. We have these methods here: from keys, clear, copy, get items, keys, pop items, set default, update, and values. We could also use equal to, because that implements that. So we could use this, and that can be used, as we know from dunder functions. We can use this to check if those two are equal. and we can print that out. That is a true. What if I change one of the values in class B, or say I add a value in class B? 4. And then if I want to try this, let me print it so that this gets printed. So in this case, we are in class B, we're doing a change, and then we are checking if it's equal. Remember, we did a copy here. So let's see if it's a deep copy or if it's a shallow copy. So in this case, what happens is class B, we have added a value. Prior to this, we printed it out, both were equal. After we added it, class B is different and class A is different. Uh, so if you understand what a deep copy is and shallow copy is, that should um, that should make you understand a lot. But if not, we'll cover that now. So in this case, we added 4 comma tran. Oh, I'm sorry, I did not use the right format here. But yeah, because these two are different, we get a value that these two are not the same. This is what I should do. Let me do this. Class B, class A dot cap dot copy. Okay, so let's do this. So what I'm doing here is I'm copying B again to restart where I started, and then I'm adding an element 4, calling it tran, and then I'm going to print out class A and class B. Then I'm going to check if they are equal. So this is what I wanted to do earlier. I don't know, my brain is not working today, but when I added the value of 4 here to tran, I got this array. Now I'm checking if these two are equal, and it says false, and this is class A and this is class B. So if we don't know what a deep copy is and what a shallow copy is, let's cover that quickly now. We have only a couple more things to cover in the hash function itself. But before that, let me quickly talk about what a deep copy is and what a shallow copy is. Okay, in this, I'm going to have a list that has one element 2 element and 3 element. All 3 elements are lists in itself. And then I'm going to do a copy statement for this list. And in this case, I'm going to print the old list in the new list. And after that, I'm going to modify this element, which is 2 comma 2, and update it to 10. And I'm going to see what the new value and the old value is. So this is called a shallow copy. What a shallow copy does is it helps in creating a new object, but it uses the original element's reference. So when I do a copy here, it just references old list, old li. It does not really copy it. This is called a shallow copy. So when I do this, when I print these two, I get the original values. Old list and the new list are exactly the same. After I change the new list, then the old list changes too. If you look at this, both the old list and the new list changes. This would be true even if I did the old list. If I change the old list, say I change the value 1 comma 2, so at this value, say if I change that to 10, what happens here is both the old and the new changes. So whether I change the old value or the new value, so in this case I'm changing this to be D and this to be 10, but I'm changing old value in one of the cases and new value in other cases. But remember, this just is a reference, it's just a shallow copy. So in this case what happens is both the old list changes and the new list changes for both the changes that I did. One I did to the old list and one I did to the new list, but still I get the same reference in both. So how do you, if you want to actually make a copy and change it, then we want to do something called a deep copy. And before I go over to deep copy, there's another way you can do a shallow copy. So let me show that. So when you just do when you just do this, it's also another way to do a shallow copy. So when you just do a lazy old li go to a new li, it does not actually copy the list and create a new list. It just does a shallow copy. So you can look at it here. So where the same logic worked, we were updating one of them and then the other got updated. We were updating one of them, then the other got updated. So this is how shallow copy works. But if we don't want to do shallow copies, there's another way to do it. That's called deep copy. And essentially it's the method called deep copy that you use within the copy library. So within the copy library, if you use the deep copy method, that changes the way we copy these two things. So in this case, it actually creates a new list, new li, which has a copy of the values in old li. So in this case, say when I change it, when I change old li, only the old li value gets changed. And when I change new li, only the new value gets changed. So if you look at this, I changed the old value 10, but the new value does not get changed. And I change the new value here to D, but the change does not happen in the old li. So that's a way to do deep copy. And just for your reference, there's another way you can actually do the new copy, the deep copy, and it's just a different it's just a different way to do it, but the concept is still the same. So when you have a list, you do this. This actually tells Python that you actually want to copy the values from the first element till the last element into a new element. So it does not actually do a reference change. It actually copies the values from the 0 to the last element to the new list. So in this case, okay, so it doesn't work that way in Python 3.8 apparently. So what I'm seeing here is, after I copy it and make a change, both of these change, and in this case as well, both of these change. What if I do 0 to it still seems to do a shallow copy. What if I do just the first two elements? In this case, we have changed the old list um, 1 comma 2, which is this, to be 10. I don't see that reference here. And in the new li, I changed the value d here in 1 comma 2. That actually gets reflected here as well. So this seems to be a value of shallow copy. I was mistaken. So this is not a deep copy. This is not a statement to do deep copy, at least in I'm using Python 3.8, so must have changed somewhere along the way. So the only way to do a deep copy is this, and then it actually changes only in the places where we wanted to change. So in old list we wanted to change it to 10, the new list we want to change it to D. So this does that. So this is a way to do new deep copy, and these two are ways to do shallow copies. And yeah, even the other way we tried was also a shallow copy. This is also a shallow copy. So that those are the difference between deep copies and shallow copies. Let's get back to hashing. So the hash method returns the hash value of an object if it has one. So hash method is an inbuilt Python method, just like every other method like length or equal to. Hash values are just integers. So when we want to hash it, we want to keep them pretty easy to work with. So the output values are just integers. They're used to compare the dictionary keys during a dictionary lookup quickly. So if the integer value is lower, it has to move up the chain. If it's higher, it has to move down the chain. So in that way, when we return back a integer, we can easily work with higher and up, lower. So that's the reason we use integers. Hash method, you can call the hash method only for immutable objects. So you can call them for ints, floats, complex numbers, strings, tuples, frozen sets. You can't call them for like any mutable values, like lists, byte arrays, sets, dictionaries, or any new classes that you define, unless you explicitly define a hash function for it, you cannot call any of the class instances with code. So let's try I is 11. Let's try calling a hash function of 11, or let's just call it I. So that is going to hash it back to 11. So what if I call it, so I get back this. If I call it with a string, hello there, and then I try to hash it, we get a hash value which is a negative number, but it's if I change one particular value here and say hello there 1, that's going to change the hash value completely into a completely different value. So this way Python makes sure that we have very different values for hashing. In an instance where you have a lot of computers, we use hashing, like we want to hash your server name. Say your server name is SNS2301. You want to hash that so that you pass on certain request IDs into this server. Then we pass that on to this hash value. Say the second server name is SNS2302. Remember, this is a negative 633, a large number. So look at this. This is a negative 682. And if you do a server number 2303, you get something completely on the other way of the equation. So this way, we have multiple different values we get, even if the server names changes only a slight bit. So in that case, we used the strings to do that. As we spoke earlier, we cannot mute, we cannot use this for like lists or dictionaries. So we had a list here. So let's try this list. If I want to hash this, unhashable. Same for a dictionary. We had a dictionary earlier called class B. Let's try that. Immutable type dictionary. So the hash function only works for immutable types, and it does not work for mutable types. If you so there's a concept called consistent hashing. What consistent hashing does is, like we want to have hash values that are uniformly distributed. So whenever we have a change in the server name, we want that to be consistently distributing those server loads into those particular hash values. So whenever we one of the server goes down, we remove that, and then we want to add load from another server. We don't want to have too much redistribution of the load to the server. So most request IDs that are going to server 1 should still go to server 1. When server 1 is down, that load should get distributed to other servers, and then when server 1 comes back up online, those distributed loads should come back to server 1. So to implement that, we implement hashing, and we use consistent hashing, which is one type of hashing that we use that helps us achieve like uniform distribution of load and to avoid a lot of redistribution. So consistent hashing not only helps us uniformly distribute the load across multiple servers, but you also are able to redistribute minimally whenever you add servers or one of the server goes down, or when the server gets back up. the redistribution of the load is very minimal. So that's something where we use it. So remember that we can hash all the values that are like strings, tuples. We cannot hash dictionaries, lists, sets, uh, and we can hash classes if you implement your own hash function on your class. Okay. The last set of thing we'll look for today is hash function can be used to map a data of arbitrary size to data of fixed size. Say, for example, we have a set which has like a million items. You can hash it to get one value, like we saw here. We hashed this whole thing into this, and if you have a list which has like 1,000 elements and so on and so on, we still can hash it into a list. Sorry, not a list. A tuple. If you have a tuple, and say it has a million elements, you can still hash it into a value which is like a, a usable integer number. So even if it has an arbitrary size, we can hash it into a fixed size. This helps easily to build key index values within the working principles of Python. So if you look at this, let's try this. So what hashing algorithm we use is very important. I think those hash values are from a earlier version of Python, so I'm just removing those. So Python like keeps updating itself, so things change as we go along. But essentially, what we want to know here is that to be able to use a very good hash function, like typically we use the built-in hash function that Python provides. Sometimes we'll have to go out of that hash function. We'll have to use something else, and there are other hash functions we just talk about right now, from something called hashlib library that Python programmers typically use. But how will you choose your hash function, right? So to have a good hash function, it has to be easy to compute. You can write your own hash function and say, okay, just all the values are going to be integers. Just um, like find out the remainder when you divide it by 5, and then multiply it by some number, and then add certain things. We could write your own logic to compute it. That can be one way to do it. But essentially, at the end of the day, the hash function should be easy to compute. It also has to have a uniform distribution. You should not have like most of the values falling under one category or one hash number. Like it should distribute them reasonably equally. So there should be a uniform distribution. You don't want to have clustering, that is most of them going into certain clusters or certain areas. And the most difficult part of hashing algorithms is we should have less collisions. Collisions are where hash value of 1 and hash value of 7 are the same. That is a collision. So that means both of these elements, when hashed, they they get to the same hash value. We should avoid that. We should have as minimal collisions as possible. Again, all hash functions could have some collisions, like even the best algorithm has some collisions. But as far as it's like 1 in a billion or 1 in a trillion, that's fine. But you cannot have like number 1 and 7 have the same hash value, it will not work out. Or say string uh, answer and answer 2 have the same hash value, that will not work. So we'll have to build a function that does not have the same hash value. Um, so if you look at this, like what we were seeing earlier is that the hash value of 0 and the hash value of 1, let's also try the hash value of 2. Okay, the earlier version of Python, the hash values were pretty close to each other, and now I'm seeing that they are not that close to each other. They may be, these two may be slightly closer to each other, but still I think they have a few extra digits here. So probably not pretty close to each other. They're very different. But say they're very close to each other, they could not have a uniform distribution. So in that case, you can actually go to a hashlib library, and some most lot of people use the MD5 hash, and this is used in cryptocurrency, in bitcoins. So in all those things, you will find the use of this hashlib library. The MD5 library is pretty important, and that can help you get along with those principles better. So that is a good introduction to hashing that you would use in your real life. And with that, we end today's session and the Python advanced training for this week. Thank you so much for joining. As always, please subscribe and hit the thumbs up button. Um, if you have any questions, always let me know in the comments below, or you can email me at ananth, ANANTH, at toptechgurus.com. Thank you so much for watching. Have a great day. Bye.